Hello and welcome to another one of D's ADD videos. Today we're going to be looking at statistical graphs. There are many different graphs that can be useful in different situations. Are they descriptive? Do you need to look at the distribution, percentages, whatever the case may be? Alright, so first type of graph that you might encounter is a pie chart. Okay, and this is the amount of pie yet to be eaten, and that's the amount of pie I have eaten. Actually, probably be the other way around in my situation. But what we're looking at here is division of a whole, a proportion or a percentage. So 80% of the class passed, 20% failed. Okay, whatever the case may be, you're looking at the data set. And those are pretty straightforward. What you'll be asked to do is come up with the proportion, where you take the frequency over the total frequency, or the percentage, where you take that number times 100. And then you'll divvy up the pie into pieces that represent roughly 20% of the pie in this case, and 80% of the pie. Bar graphs and histograms. The y-axis can either be frequency, it can be proportion, or percentage, like in this case. This is a bar graph because we have categorical or qualitative variables here. Alright, so that's why they're not linked together like this histogram, which has a numerical x-axis. Either way, you can see the distribution of the data. We actually happen to have cumulative percentage, so this should be an ogive or ogive, or however you pronounce that. But we'll go into detail on how to find those later. Alright, and then we have a stem leaf plot. A stem leaf plot is basically a way of looking at the data, actually seeing the numbers, and kind of being able to see a distribution there. Do you see it? So if I'm looking at this, if I were to turn it on its side, I could see kind of the histogram coming up there. The stem is everything but the last number, and the leaf is the last number. So the way you would read that is 10, 13, 16, 21, 26. Get the idea? 41, 41, 45. Now, let's say that there was a double stem leaf plot. That would have one group to the right and one group to the left. So 0, 2 is 2, 0, 2 is 2 again. Here we have 0, 9, 0, 4, 0, 3. All right. And then here we have 38, 35 in one group, and 31 and 35 in the next group. So you can compare the groups just by looking at it and get a quick visual idea of what's going on between the two groups by looking at the data in a stem leaf plot. In this case, a double stem leaf plot. And then we have these scatter plots. You've been dealing with scatter plots ever since algebra. I got some of these royalty-free images on the web. This looks like it's hot water gallons per day compared to the electricity usage. So the more hot water you use, you got to heat that up using electricity. So the more the cost will be of your electricity. So you can see when you plot all these x versus y points, that's what a scatter plot will be, you get this rough trend. Later we'll talk about regression lines. It looks like there's a regression line fit through the data. It's a line that's best fit. We'll talk about how we do that. That looks like it's the regression equation right there. Okay, so now knowing the number of gallons, you can predict what your kilowatt hours is going to be. Usage. It was usage, not cost. I apologize. All right. So that's a positive correlation. One went up and the other went up. Now this is a negative correlation. Okay, that just means as one variable goes up, the other one goes down. So as the price increases, as the mileage increases of whatever vehicle, the price decreases. All right. So here's another regression line. Talk about R squared later. Coefficient of determination that basically predicts how many of these points actually lie on the line that we best fit. All right. Here's another positive correlation. More problems, more money. Oh, sorry, other way around. More money, more problems. think that's the only time you'll ever hear me quote Sean Combs, or AKA P. Diddy, or whatever he's calling himself nowadays. All right, so either way, you can see there's many different ways of looking at data. This could have been time here, and this could be some time series data where you look at whatever you're looking at over a time frame. But you just got to make sure that you're okay with it. Earlier I talked about relative frequencies and frequencies. This is just what that means. If I'm looking at grades for your first test, for instance, and find out that there were 3 A's, 4 B's, 2 C's, and 1 D, well, these are the frequencies, how many of each grade there was. And then if you take the total frequency and take each one divided by the total frequency, we get what's called the relative frequencies. These should all add up to 1. They're proportions. And when you take that proportion multiplied by 100, you get the percentages. So this would be 30% made A's, 40% made B's, 20% made C's, and 10% made D's. So you could make a pie chart out of this if you wanted to, where the biggest slice of pie would be B's, then it would slightly smaller would be A's, even smaller and even smaller. Okay? So these are just some questions I answered to a student. But make sure you know your symbols. We're going to be going over probability here in one of the next videos. Make sure you practice as many of these as you can. You'll find out that the graphs in statistics aren't too bad. All right? You might have a little trouble with histograms depending on how detailed your teacher or professor wants you to get. So practice, practice, practice. I hope I helped eliminate any confusion enough for you to get started. Thank you and have a nice day.